Guys, welcome back to another Mechanical Minute. Quick videos and random relevant topics that pop up, keep and reference as needed. This time we're going to talk about misfires. Misfires are a huge topic and hard to squeeze into a Mechanical Minute video, but I felt compelled to touch on this subject, so here's a basic rundown of the topic. Really want to cover some quick diagnostic scenarios with this video. Misfires happen in every engine. That's a fact. A running engine is quite literally a series of controlled explosions, and misfires do happen. The severity and how often they happen is what we see as a problem. In most engines today, misfires are counted by watching the crank speed during each firing event. If the cycle shows crank speed to slow when it knows the cylinder is in ignition stroke, then it can assume the explosion did not happen to increase crank speed by pushing the piston down forcefully, and it counts a misfire. Most PCMs have parameters set to only flag misfire issues if it sees so many within a set time parameter. As stated, all engines have misfires every so often, so we don't want to light on every single time one happens. If the misfire count reaches a number above a specified limit within the time threshold, the PCM can assume a problem exists and commands a check engine light. When we diagnose misfires, we have to understand that they can be caused by a huge number of issues. From worn out plugs, coils, wiring, faulty or clogged fuel filters, poor fuel, insufficient air, injectors, mechanical failure, cylinder compression issues, cylinder heads, lifters, camshafts, valves, sensors, PCM programming, and much more in all gas and diesel units. When diagnosing misfires, there are a few quick preliminary things we can check to narrow the issue down pretty fast. These include PCM data first, always first, to see if the PCM sees random misfires or specific cylinder counts. This is real important to know. Fuel trims for bank 1 and bank 2 show a lot as far as if it's a rich or lean misfire, and if it's the whole engine or just one bank. Remember, long term is what the PCM sees, and short term is what the PCM is doing to correct. OTA is what the PCM sees in exhaust leaving the cylinders, bank 1 and bank 2 comparatively. Also pay attention to the codes themselves. PO 300 codes, 300 to 316 are misfire codes, and 200 codes are usually fuel injector circuit or fuel issue codes. That can narrow it down pretty quick too. PCM data will show a count if it's consistent, as in a dead hole, or just random multiple. That's good to know. And also, we can see what the computer sees for fuel pressure, because that's relevant as well. Aside from all that knowledge we just looked at in the data, we can also do a few other things quickly to narrow it down, like remove and inspect the condition of the suspected cylinder's plug and then swap it into a neighboring hole that did not show a misfire to see if the misfire moves with it. We can do the same with the coil. I tend to swap one hole in the coil to a different to differentiate the plug from coil. So basically, if I have a misfire in cylinder 3, I put the plug in 1 and the coil on 5. And then I know if the misfire went to cylinder 1, it's the plug. If it stayed in cylinder 3, it's mechanical. And if it went to 5, it's the coil. We can use a spark tester so we can physically see the spark. We can verify injector pulse with a Noid light or circuit tester. Can verify fuel pressure mechanically with a gauge. And if after moving the coil or the plug, the misfire stayed in that cylinder, we can do a relative compression check with that cylinder compared to the ones that do not have a misfire. We all know that engines need all 4 strokes, suck, squeeze, bang, blow to run, or in technical terms, intake, compression, ignition, exhaust. We tend to check the bang first because it's the easiest to get to and the most common failure. The bangs are controlled by external sources such as fuel injector, plug, or coil. Compression is crucial for a good explosion, especially in a diesel. To see compression, we rely on a gauge, as we can't generally see into the cylinder without a lot of disassembly. A compression gauge will tell us a lot. The suck and blow portions are the valves operating and sealing properly. These can also be evident with a compression gauge. A borescope can also help in instances when we know this issue is in a single cylinder. Ideally, we would never sell a tune-up for a misfire issue unless we have verified the misfire seems to be a random multiple cylinder, as it's less likely to need a tune-up if it's 1 or 2 specific cylinders. Not that it can't be the problem, but throwing a tune-up at it is pretty much setting yourself up for failure about 50% of the time. Customers don't like spending hundreds of dollars to hear it didn't fix it, especially when they're being charged for diagnostics. We should always verify the stuff we just went over. If it does end up being a tune-up, it's usually evident with plug electrodes worn down, coil carbon tracking, burn through in the coil boots. The misfire moves with the plugs or the coil, and compression is good in the suspected cylinder. Also, another quick tip, never rely on cylinder contribution data. That's really just a starting point, and all it can really tell you is what cylinder, just like the misfire counts. It does not tell you if it's spark or fuel or compression related, so don't rely on it. So if you have a good scan tool, Noid light, spark tester, compression tester, you can do some pretty good misfire diagnosis quick. And always, if you know how something's supposed to work, you can better tell when it don't.